Hi everyone, welcome to my YouTube channel. In this video I am going to explain you one of the important topic of quantum mechanics, that is beginning of the quantum mechanics, how actually the quantum mechanics has been developed and how it has been introduced as one of the branch of physics. So before going to start, if you are new to my channel, please subscribe my channel for upcoming videos. So let us start. Origin of quantum mechanics. So first we should know the definition of quantum mechanics. Quantum mechanics is a physical science dealing with the behavior of matter and energy on the scale of atoms and subatomic particles or waves. So quantum mechanics basically deals with the study of microscopic particles. In the 19th century, we used to apply the Newton's laws, that is related to classical mechanics. We need to explain all the physics concept with the help of Newtonian mechanics, but it is applied to celestial objects but not to the subatomic or atomic particles. That's why the quantum mechanics has been introduced. So the term quantum mechanics was coined by Max Born in the year 1924. The acceptance by the general physics community of quantum mechanics is due to its accurate prediction of the physical behavior of systems, including systems where Newtonian mechanics fails. So this is how actually the quantum mechanics has been introduced, because classical mechanics fails to explain some of the concepts related to atoms or subatomic particles. Classical mechanics satisfactorily explain the motion of celestial bodies such as planets, stars, and the microscopic as well as microscopic terrestrial bodies moving with non-relativistic speed. So theory of relativity was explained by Einstein. So any of the objects that having the velocity less than the speed of light, they can be explained even though microscopic particles, but still classical mechanics fails to explain many of the events. So first among them, so the first one, classical mechanics fails to explain the motion of an electron proton inside the atom. If we take atom, it consists of microscopic particles like proton, neutron and electron. Proton, neutron exist inside the nucleus, whereas electron revolve around the nucleus. So that was not explained by classical mechanics. It is failed to explain the motion of these particles inside the atom. Second one, the classical mechanics failed to explain the stability of atom. So how actually the atom is stable? It is made up of anyhow positively charged particle like proton and negatively charged particle like electron, and whereas neutron is neutral. So how exactly the atom is going to be neutral? By making of positive and negative charges, because there is a force of attraction we call that is Coulomb's law. According to that, two equal and opposite charges attract each other. So that theory was not explained by classical mechanics. So the another one, it failed to explain the observed spectrum of black body radiation. So classical mechanics also failed to explain the black body radiation spectrum. Black body is the one which absorbs all the radiations falling on it. So if we take black body, the spectrum, you can see here the diagram here, the energy density versus frequency. If we plot the graph for the black body and for different temperatures, if we take, we have the absorption peak here. Okay, so this is nothing but at equilibrium, the radiation emitted has a well-defined continuous energy distribution. If you see the curve, this is what continuous distribution. So this is at equilibrium. It was explained by the scientists called Wayne and Rayleigh and Stephan. So this is another drawback of classical mechanics, and that was explained by quantum mechanics. So Planck's quantum hypothesis or Planck's energy density distribution, if we understand, we can clearly come to know that how exactly energy is going to be, whether it is discrete or continuous in nature. So he postulated that the energy of the radiation or frequency nu emitted by the oscillating body, that is from the walls of the cavity, must come only in integer multiple of h nu. So that is, energy is not continuous, it is always discrete in nature. That was explained by Planck's, the scientist name, and that's why we call the quanta of energy, h nu is what? Quanta of energy, that is not continuous, it is going to be discrete. Here n takes the values of in 0, 1, 2, 3 and so on. So h nu, as I said, is the energy of quantum of radiation. So the another drawback of classical mechanics, if we take the classical mechanics could not explain the observed variation of specific heat of solids and gases. So it is not explained by classical mechanics, so that is successfully explained by again quantum mechanics. So fifth one, if we consider the classical mechanics failed to explain even a simple spectrum of hydrogen atom. So first atom, if we take, that is hydrogen. Even for hydrogen atom, classical mechanics could not explain the spectrum. So that was successfully explained by the quantum mechanics. Sixth one, that is classical mechanics could not explain the phenomena such as photoelectric effect, Compton effect, and some of the important phenomena. So these all concepts are related to what? Atomic or subatomic level. That's why the laws of quantum mechanics are not applicable for the microscopic particles. So that's why the quantum mechanics has been introduced. If we take photoelectric effect, that was explained by Einstein. He has been awarded Nobel Prize for that. So if we want to define photoelectric effect, we can define it as the emission of electron from the metal surface when irradiated with light. You can understand with the help of diagram. Whenever light is going to incident on the metal surface, electrons are going to be ejected from the metal surface. So incident light, nothing but having the photon of energy h nu. Due to this energy, electrons within the atom are going to be ejected. So this we can denote it by formula h nu is equal to W plus K. K is what? The kinetic energy that has been given to the atoms or the electrons. So here W relates to the work function. If we want to write the formula for kinetic energy, that is equal to h nu minus W, or else W is equal to also the work function related to the ejection of electron, that is h nu naught, initial frequency. So this is how the photoelectric effect or the phenomena is going to take place, and that is successfully explained by Einstein. So the next important phenomena, that is Compton effect. In the year 1923, that was explained by Compton, the scientist name. So he found that the wavelength of the scattered radiation is larger than the wavelength of incident radiation. We can understand with the help of diagram here. If let us say photon of energy having the wavelength and the energy, that is h nu, is going to interact with the electron. So once the incident photon is going to interact with the electron, after scattering, its wavelength is going to be increased than the incident light. So due to scattering, and the electron, that is we call it as recoil electron. So initially it has the photon of energy h nu. Once it is scattered, by making an angle theta, its scattered photon energy is given by h nu prime. So its wavelength is larger than the incident wavelength. So that was successfully explained by Compton, and the formula for the shift in or the change in wavelength, we can write it as lambda initial wavelength minus lambda prime minus lambda. So change in wavelength to the initial wavelength of the incident light, that is equal to h divided by m into c, speed of light, into the it is making an angle theta for the scattering, that is 1 minus cos theta. So this is how actually the beginning of quantum mechanics has happened, and whatever the microscopic particles or the objects we come across, we can successfully explain with the quantum theory. So this is how the quantum mechanics has been developed, and it is very helpful to understand the concepts at atomic or subatomic level. So thank you. I hope this information is helpful, and how you are going to understand how exactly the quantum mechanics has started or has developed. Thank you for watching.